Greetings, the Astro30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Today I'm going to be re-looking at this Harman Kardon CD player that's dead. I do have the replacement PWM IC for here, but I want to do a preliminary test because in the last video I messed up how I was testing things. Now I believe I just measured on the screws here for the ground. Now when I was measuring the high side voltages, well, this ground and the case is not related to the negative DC rail here on the main filter cap. They're separate. The actual grounds over here and on the plug connector come off the secondary of the transformer. My bad. That would explain why after DC rectification the AC mains voltage coming in was only 218 volts, because it's a different ground, it's not related. So, and the next thing I want to do is actually absolutely make sure 100% that this IC is not oscillating. Excuse me. And there's a transistor over here marked Q1, which is a series pass regulator from what I could gather on the schematic. And we just need to see that there's, I believe, 12 volts on the emitter. And if there's no voltage there, well, that's a problem. So I'll be using a scope to probe the drain pins on the IC here to see if we got roughly 50 kilohertz, I believe is what this thing oscillates at. But to make things simpler, I'm going to pull this board out and I'm going to solder a wire from, well, the negative of this capacitor and stick it out here somewhere where it won't short on the case or anything. Now, word of advice, if you're doing something similar at home like this, switch mode power supplies are considerably dangerous. So if you don't know what you're doing, you do so at your own risk. So you've been warned. There's like 360 volts DC around just this filter cap alone. So keep that in mind. Now this has been off for a couple of weeks, so I'm not worried about getting an electric shock off the capacitor or anything. So let me pull the board out and I'll solder a temporary fly wire onto this capacitor so I can do some proper voltage measurements on the high side at least, and check that IC's oscillation status. Now, I don't know if I mentioned it in the last video. I've got the power supply out in my hand. It's actually printed on the silk screen here, risk of electric shock. See that? Risk of electric shock. And it says the same thing on the schematic too, by the way, which is weird. So it's misspelled. That's real good quality control. They can't even spell the word shock. Anyway, let me get to putting that wire on. Alright, just got a piece of wire soldered to the negative of the capacitor here. I've got to be careful this does not short. So I turn this on to voltage DC, and well, I might as well turn the DC, the dim bulb on. So I believe it's this resistor here. Well, it's still only saying 218 volt DC, which is odd. And there's still only 0.08 on the other side of it. That's weird. So yeah, I don't know why it's being held down. And there's nothing at that emitter. I believe that's the emitter. I'll just try and go around the other side of the transistor here. Nothing there. Yeah, there's nothing there at all. That's disappointing. So why we've got no voltage higher than 218 volt DC is beyond me. This is really weird. Right, the thing is off. Now, at the emitter of this transistor, there should actually be 16 volts, according to the schematic, not 12. But there's only like 0.08 there. So it's at the legal limit to drive in America, but it's not very helpful for the circuit. Now, there's 218 volts across these drain pins of this PWM IC, but then again, that's because one side of the primary of this transformer up here is connected directly to the positive rail. So, and the other end of the primary is connected to the drains, so that makes sense. So if this is not oscillating, which I don't think it is, then yeah, it's going to cause the issue. But why the voltage coming off of here is next to nothing, I don't know. And this is a 2N5551 transistor, so it probably might be in my best interest to double check that that's still even conducting, because, well, there's nothing worse than a transistor that doesn't work, because you'd think it would. Now, this is an NPN transistor, so it's got a positive base. Now, I believe the pinout is emitter base collector, so I'll just go across the base here. The thing is off. 0.6 of a volt there, which is fine. As for the other side, which I believe is the collector, 0.6 of a volt. So the emitter should be higher. Yeah, so that left-hand pin is the emitter, definitely. So between emitter and collector, we've got 0.5 of a volt in that direction, and in the other direction 0.7 of a volt. So that's kind of interesting. Really, there shouldn't be anything across that trend. There's no components across the emitter and collector like a diode or anything. So yeah, that's kind of interesting. What I should do is I should take this transistor out of circuit and test it out of the unit. I'm going to get rid of this ground lead now. I don't really need it anymore. Alright, transistor's out of circuit, so I'll just do the collector to emitter junction again. Make sure that I'm in the meters in shot, of course. If I can get the leads to connect. Right, there is nothing there, so that flipped over handily. Right, there's nothing, well, there wasn't, hang on. Yeah, there's nothing across the emitter collector junctions. So as for the conduction of the transistor, it's still conducting fine, so there is nothing physically wrong or electrically wrong with this transistor, and it's still conducting correctly. So I'll bring in this PCB and I'll measure across where that transistor used to live, which is here. And we don't have anything now. There is absolutely no conduction across those pads. Oh wait, there it is. 0.5 of a volt. But there's nothing in the other direction. So that's kind of interesting. Well, at least I think it's interesting. But what I think it is because the collector, which is this one, is connected across another primary of the main transformer here through a diode, a fast recovery diode. And the emitter, which is this, goes through a 10 ohm resistor, which then goes through, well, another 10 ohm resistor, through another fast recovery diode back to the center tap of the second primary. So that's maybe where we're getting that 0.5 of a volt from. It's probably from there somehow. I mean, it is possible. But there's nothing physically wrong with the transistor. So I still think that there's something wrong with this IC, but I really should resolder all the joints on the primary side, to be honest. But I'll pop this transistor back in and resolder him back in, because, well, there's no need for it to be out now. So yeah, I don't know at this stage, to be honest, what's going on with this circuit. But the fact that we're missing the 16 volt voltage there, it's possible that something in this IC is just simply holding it down. So I might change the IC anyway whilst I'm here, because I've got 4 of them. It was only like about $4 odd US or something. It wasn't that expensive. I was supposed to get 5 of them, but I only ended up with 4 because they miscounted. So that's the transistor back in. So I might as well pop this IC out. I mean, it couldn't hurt, but I don't really want to be sticking an oscilloscope on the, just trying to clear my desoldering bulb. I don't want to be sticking an oscilloscope on the high side on this IC to measure the oscillation with 218 volt DC there. Lucky this PCB is only single sided, it makes desoldering stuff a lot easier. See if I can get this IC to agree and come out. Just gently pry it. There is a spare removal tool for ICs, but I don't have one. I used to have one, or maybe it was an inserter. I think I had an IC insertion tool, but I never had a removal tool. It's just like a pair of backward tweezers. Yeah, I want to try and get this out without damaging it. Bending that capacitor over. Come on. There we go. One IC extracted. I don't see anything physically wrong with it. So I'll grab a new one wherever I put them. Right here. These came from China, so I have no idea if they're any good. Apparently I can get this from Wagner too, but I didn't realise that until someone commented on the previous video and said that you could. And they're like about, I think it was about $6 or $7. Now, I've got to get this. Why did they mark that Q365? Anyway. Alright, new ICs in. They are slightly different part numbers, but I was going off what the schematic said rather than what the chip said. So this will either work or fail catastrophically. So here we go. Well, nothing unusual happened. And it is still dead. And now it's ticking. We've got a standby light now. Ha! It works! Look at that, we've got a display. So, I don't know why it started ticking and then started working before, But I actually moved the camera to this position and then forgot to record the last part, so I've got to re-record it, but that's alright. I've actually turned it off and turned it back on again, and it didn't tick this time, so whatever it was, I don't know, but it opens, which is good. It closes, and the laser is working, so you guys can watch the laser block assembly. There we go. So I might try putting a disc in and see if it reads now. Reading, it says. Yep, 3 tracks, and it's only 3 tracks on the disc. Play. It's playing. However, this CD player runs at a different speed to a normal CD player on the spindle side. See how fast that disc is spinning? That's spinning around about probably 10 times the speed of a normal CD. That is because this particular CD player can actually read MPEG, i.e. a 700 megabyte CDR or CD-ROM, and yeah, that's why it spins at that speed, because audio doesn't need to be spinning that fast, but data does. Anyhow, it's counting away just nicely. It doesn't appear to be skipping in any way, shape or form that I can see. So I'll just skip to the next track. And it seems to be fine. I can't see any issue with that. So I've actually fixed something for a change. Let's see if, what does the display button do? Oh, it just dims it and turns it off. Why you'd want to turn the display off altogether, I don't know. That just seems strange to me. Forward search. Oops. That seems to work. Pause. Yeah. Resume. Nice. Stop. And eject. So what I'm going to do now is I'm going to change dim bulbs, so I can actually try bypassing it and make sure it runs directly off the mains correctly. I mean, it should. Turn it off. It even says power off. How nice. And when it's plugged in, there is a little standby light on the side, which actually glows white when it's turned on. So that's nice. The power supply is now functioning okay as far as I can tell in this unit. So whatever's actually wrong with this old IC was holding down the VCC supply pin line, which is pin 3 on this particular IC. And yeah, but that initial tick, I don't know what that was. I did resolder some joints here on the high side, so it may have been a combination of that and the IC, and then it just suddenly came back to life again. Who knows, but a ticking power supply is never actually a good thing. Alright, I got it hooked up to the other dim bulb now. Nothing unusual, so I'll turn it back on. It powers up perfectly fine, so now I will bypass, which is that one. Now we're at full line voltage. There is absolutely no issue. Next thing to do would be to hook it up to an amplifier and see if it actually outputs any sound. That might be a good idea. I've got to find an RCA lead because I don't really want to wreck into my amplifier over there in the corner and unhook things just to hook this up. So I'll go downstairs into the garage and have a look for another lead. In the meantime, I'll turn that off. Well, I couldn't find a stereo lead, but I found a mono one, which will do. Well, that's annoying. It's fouled again. Well, that was short-lived. I've put it back together and I've disconnected the mains input to the power supply just for safety, because I don't want it being plugged directly into the wall and it catastrophically failing. Something now has completely shit itself, because all I did was left it turned off for 5 minutes whilst I went downstairs to look for a cable, and then came back up and it just shit itself again. So either something's gone short circuit now, or the new IC has failed, which is unlikely, or the main filter cap is probably bad. But I don't really want to invest any more time or money in this because, well, it's not really that tenable for me. So I'll return it to the owner. I'll explain my findings. When I had both dim bulbs in circuit, unbypassed, I could hear the power supply was starting to scream. So the transformer was getting oscillation from the PWM controller IC, so I don't know what's gone on. Either that or another part has failed, but it's probably most likely the main filter cap, maybe shorted or going short. It's possible, I don't know. As I said, I'm not going to invest any more time or money in this. So I've put it back together, disconnected the mains lead as I said, and I'm just going to return it to the owner. Yeah, I'll still upload this video. Someone may enjoy it, I don't know. It's unfortunate I didn't repair it. Well, I did for a few seconds, and then when I went to actually test to see if it had any audio output, well, it was all over. Anyway, I'm going to leave this video here. Leave your thoughts below in the comments. And if you're not subscribed, please remember to go down below and subscribe. Like the video and, well, comment, as I said. Anyway, this is Joshua saying, see ya. Have a great day. It's unfortunate, but...